Today we are going to learn a bit more about chords. Hey, not you again, shoo! Anyways, the next theorem on chords states that the perpendicular from the center of a circle to a chord bisects the chord. In human language, this basically means that if I draw a line from the center to a chord that is at right angles to the chord, the line will cut the chord into two equal parts. Let's see if we can prove this. If we make two lines from the center of the circle to the ends of the chord, we get two triangles, APO and BPO. And if history is right, as long as we can prove that these two triangles, APO and BPO, are congruent, we should be able to prove that the lines AP and BP are exactly the same length. And this in turn would prove that the line OP bisects the chord AB. So let's get on to the proof. So it's clear that these two angles, APO and BPO, are 90 degrees, right? Which means that they both are equal. And the sides OA and OB are both the radii, so they both are equal too. And the side OP here is the common side for both these two triangles. Thus, the hypotenuse and one side are equal for the two triangles. And they both have a right angle. So using the right angle hypotenuse side congruence theorem, the true triangles APO and BPO are congruent. So this means that the remaining sides should also be equal. Hence, AP and PB are equal. Therefore, our theorem is proved. Now, we can also use congruency to prove the reverse of this theorem. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So, according to this theorem, if the line OP bisects the chord, the lines AP and PB are equal. Once again, the lines OA and OB are the radii, so they both are equal as well. And since the line OP is the common side, it is equal too. So with three equal sides, this follows the side-side-side congruence theorem and proves that the triangles APO and BPO are congruent. Now, to prove our theorem, we have to show that the line OP is perpendicular to the chord AB. Since we just proved that these two triangles are congruent, the angles APO and BPO must also be equal. This means that the line OP is actually an angle bisector of the chord AB because it cuts the angle into two equal angles. Since the chord AB is a straight line, the angle here is actually 180 degrees. So the half of 180 is 90. Thus, our theorem is proved. Before you move on to the next video on theorems, try and see if you can solve this puzzle. Imagine you have three collinear points. How can you draw a circle which passes through all of these 3 points? Watch the next video to find the answer.